Good day, everyone. In this video, I'm going to show you how to estimate IV regression, and how to estimate a model using IV regression and two-stage least squares. Now, again, based on the lectures and the lessons that you have probably encountered, we use IV regression if you suspect that the variable of interest, your independent variable of interest, is endogenous, such that it's correlated with your error term. In other words, you're violating the zero conditional mean assumption, which could be coming from different sources, like, your independent variable might be correlated with a factor that is not observable, right? Or not measurable, and of course that's omitted from your main model, and that would be lumped on your error term, and that will cause the endogeneity. It could also be an issue of measurement error in such that your independent variable has a measurement error. Usually happens with income. Really happens with some variables that people don't really want to be honest about. So that measurement error is lumped in the error term, and that will cause the problem of endogeneity. Right? Now, we cannot use OLS in the presence of such endogeneity. That's a reason why we're using IV regression. So let's try to estimate such model, by using one of Woolridge data sets. Let's try to use wage. This is a typical example of a typical data set used in these exercises, but they're pretty useful and very intuitive. So let's try to use this. So let me just save this first. Okay. Place. Okay. All right. Now, before we do IV regression, let's try to estimate this model first using your usual OLS. So let's try to regress L wage, edu experience, tenure, and dummy variable for race black. And let's use heteroscedasticity robust standard errors. Right. So this is the results. Looks promising, but suppose we suspect that education is endogenous. A person's education could be affected by some other factors, like, I don't know, birth order in the family or number of siblings in a given family. So the idea is, if you have more siblings, then you're less likely to be more educated or reach a higher level of education, because limited resources. Your parents may not be that well off to support your studies. Right? So let's bank on that idea that education might be endogenous. So might be endogenous. So we use SIBs. Let's try to use siblings, number of siblings, as an instrument. So to estimate a 2SLS, to estimate a model using two-stage least squares, it's pretty straightforward. Still OLS, right? Still OLS, and the execution is pretty simple. So let's just type IV regress 2SLS. You have L wage, you have expert, tenure, black, but will indicate that educ is endogenous, and we will use SIBs as an instrument. So you still include heteroscedasticity robust standard errors. There's also an option to include the first stage regression. Recall that this is a two-stage least squares estimator. So you have a first stage regression that purges the endogeneity from edu, because we assume that siblings is, exogenous from the model. So if this is estimated and we get the fitted values of education, we're basically obtaining the part of edu that is not correlated with the error term. So we can include the option first. Okay, so let's run this. So this is your first stage regression, right? This is first stage regression. It sort of satisfies our order condition, right? Order condition suggests that your instrument should be correlated, right? Should be correlated with your endogenous variable, in this case edu. So looking at the significance of siblings, and it's sort of intuitive. So you have more siblings. Having more siblings reduces your years of education by around 0.17 for each additional sibling that the person may have. Right. So it's statistically significant, satisfies our satisfies one of our assumptions. Right. You have your order condition that sibling should be, should be significant, should be statistically significant. And now we proceed to the second stage regression. Now notice that Stata does this automatically. So you don't have to estimate separate linear regressions, right? Separate OLS regressions to obtain the fitted values, then um, plug it in your main model, so to speak. So notice that once we account for the endogeneity of education, turns out that we were underestimating the effect of the return of education on wages, right? By around 3 percentage points, right? So it turns out the actual effect of education, the actual returns to education, when we account for its endogeneity, is around 9.4% as opposed to 7 or 6.9% when we use OLS. Now we can also do the same for RStudio for R. Right? It's pretty based on the manuals. It's pretty straightforward to estimate an IV regression using R. If you don't have Stata, don't worry. You can still use R for estimating IV regression, estimating linear models using IV regression. So let's try to estimate the same model, right, as with the other one. So let's try to estimate OLS first. Right, so let's try to have M1 linear model, right, wage, simple model, educ plus experience plus tenure plus factor. You have factor variables. And your data is DF. Let's try to run this. Okay, and let's try to get the summary of the data. So summary 1. And we have the results here. We have the results here. It's still identical. It's still identical with our earlier results. It's still 6.8, 6.9% returns of education or to L wage. Right? But we suspect that L wage, or we suspect that edu might be endogenous. So to do so, let's try to estimate another model using IV reg. So there's an IV reg option here. So we have L wage, educ, sorry, we have experience, and so we type our model. So we have educ plus your plus factor black. Now we will include the equation here, right? So since educ is the endogenous variable, we'll exclude that and we'll include these other regressors along with the instrument. So we have SIBs as the instrument. We have exper plus tenure plus factor black. And our data is still DF. Okay, so let's try to estimate this. Oh, there's no iVreg yet. I think we have to install the package first. Right, now that the library iVreg is loaded, let's try to run this. All right, so you have M2. And then let's get the summary of so we still get the same results. So now after accounting for the instrument, after accounting for, sorry, the endogeneity of education, you have your returns now clocking in at 9.3, 9.36. as opposed to the results of OLS, which is just at around 6.8% per additional year of education. Now, if you wanted to estimate, you wanted to compute for the heteroscedasticity robust standard errors after IV regression, which is the advantage of running it in a single syntax or a single command, you can type in coef test. You have model 2. Variance covariance matrix should be H, and let's type in the type. Okay, let's try to include the library first. Oops. All right, guys, so I have to load the library LM test. Right, so let's try to get the heteroscedasticity robust standard errors for M2. Okay. Sorry, that should be V for VHC. So let's run this. Oh, still not here. Sorry about that. All right, sorry for the skip. So I had to install, had to load the library LM test and sandwich in order for us to get the heteroscedasticity robust standard errors for our model. So let me just run that again. Let me just run that summary again. All right, so the summary here is that you have this p-values, right? So you have your standard errors here, 0.4, but we need to use a robust set of standard errors. So in this case, let's use the coef test, right? And notice that the standard errors are slightly lower now. Right? They're adjusted. They're now adjusted, and they're now using the robust standard errors. And this is actually yeah, this is actually consistent. Somehow matches our results from Stata with the robust standard errors option. It's actually lower once we account for that possible heteroscedasticity. So there are a lot of tests here that you can still do using both R and Stata, involving two-stage least squares. You can add more instruments as you wish. You can just add them here, right, in the second function, or in Stata you can just include them in the parenthesis option. You can also have more endogenous variables as needed, right? But just make sure that you have at least one instrument. Make sure that you have at least one instrument for each endogenous variable. Right, so that concludes our short video for today. Thank you so much for listening and subscribing.